Hey everybody. Just want to tell you that this is my first time going to the Philippines. It's an amazing, beautiful country. I wish I'm going to be coming here more often. Thanks for the welcome. Alright, so identity, such an overloaded word, right? The context I'm going to use identity today is around your individuality, your uniqueness on the online platforms. Identity is what defines you, but if your identity is stolen, somebody can also define the same thing for you. And that's the reason why we are having this discussion. Now, I'm Dr. Shaw, as already been introduced. I work for Microsoft Security, and I'm going to take you on a journey to talk about identity a little bit in detail. So this is not just a big mirror glasses. It's going to be a little more intermediate understanding of what identity is. In that process, while I'm going through all the identity and the uniqueness around it, I'm going to dribble into the scenarios which researchers like you guys have found over the years and given us amazing bug reports that would actually enlighten you about, hey, what kind of issues would you actually end up finding if you start looking into this area. With that, let's move on. Right. When I was working on this presentation, I was like, okay, what should I actually start with? So then, okay, what is the best way of looking at identity from a different lens? Like in 19th century, somebody said, hey, imitation is a sincere form of flattery. We'll come back to this slide by the end of the presentation and see how good this quote holds in today's world. All right, so my goal with this talk is literally to give you guys a nudge. And what do I mean by that? I mean, I can totally sense that you have been thinking or using identity somewhere or the other, but it's been in your backpack. Because, hey, things that works just works, right? You don't really care about identity as much as you care about the application side of it. So this is kind of giving you an idea, hey, there is something which is the key to starting going into the application. That key is very vital to how everything works. And I want to open your eyes into this new horizon, which has been sidelined for way too long. So again, the goal is to give you a nudge, give an idea about identity, in the process, give you some ideas, tips and tricks of what are the weaknesses. If you start today looking into this area, what are the areas you would want to focus on? And what is the incentives? All of that will come into the picture as I go along with the presentation. Agenda is very crisp. I'm going to talk about identity. I'm going to talk about the protocol and its nightmares. The protocol is very complex, so obviously the nightmares are going to follow. A little bit of a shameless plug from Microsoft perspective, giving you an idea of what identity boundary we are actually exposing today. And we'll conclude with some heavy words, jargons and GAMs, and what you should guys be doing if you really want to get into the hacking space in the identity environment. So getting to know identity. So identity is required for what? Right? You should be asking that question first. Why do I require identity? Well, if you think about your online space in general, everything is a resource. You're trying to get to a resource, whether it's your pictures, it's your Facebook profile, or whatever, everything is a resource at the end of the day. You get it through different mediums, as all we have seen on the slides. But really, how do the application differentiate who you are from person A to person B? That differentiation is what comes through your identity. Your identity is what exposes you to the applications and say, hey, this is I am, and I want my data to be shown to me, not somebody else, right? So that's what identification is all about. A great example as an application is Office.com, which actually hosts sub-applications called OneDrive, where you host all your file shares, and then Outlook, where you have your mails. So imagine this is a happy application which has a lot of intrinsic layers around carrying into the different pieces of information that is specific to you. So when you go to this website, it'll ask your identity, like who are you? And based on that, it'll restructure its information and then show it and present it. Now, as an application, if I am out like office.com, how do I make the next progression to get to your identity? Right? So there is a specifically well-defined path to get an identity for any individuals for an application. So this is a journey which starts from the application and figure out, hey, how should I get to know your identity? Who is trying to get onto my application at this point? So 3 steps process. These are 3 different milestones. We'll talk about them in a little bit of details. So the first milestone for an application is to know, hey, where am I going to get your identity from? So what is the signing protocol is all about? So hey, I'm going to reach out to this identity provider, or I'm going to reach out to somebody else. And what am I supposed to reach with is what defines this first protocol. There are a bunch of well-defined protocols, as you can see on the right side, and people can choose and pick. Like the applications can figure out which one they want to use. The second and interesting piece is about how am I going to get that identification? I need to get your username and credentials, your username and password, and pass on to that whoever is going to give me the identity. But I need to get that information first, right? So it could be form-based, which we have seen over the years, where you have to enter the username and passwords, or it could be intrinsic in the system itself. Like if you try logging into Windows environment with your passport, like ROOTCON account, your information or your identity is already with the system. So you don't actually have to provide a username and password again. That identity which is in the system can be replayed, underlined, and given to the identity provider. This is what Kerberos is all about. And there is OpenID as well. We'll talk about OpenID as well. The third most vital piece and the last piece of the puzzle is what is getting provided by the identity provider. And this is about getting the content back from the identity provider in some form. Like if I'm an application, I need to know what did this application or what did this identity provider provided me back? In what form? Is it JSON based? Is it XML based? So that kind of detail is it base64. So it could be any different protocols that could be used by the identity provider to give you back the content. So you need to have these 3 in place to actually follow the protocol to get to the identity. And to give you an idea of a mix of what has happened, so these are 4 different layers of how you can get an identity. This is just for Microsoft. And this is not the only layers, there are more. You can imagine Facebook and Google also have a similar set of these layers which provide identity. And you can appreciate what happened on the right side is talking about various layers of protocols. They are intermixed. Like they are not like, I'm going to use this particular set. They can pick and choose which of the 3 protocols, the 3 milestones that we talked about, is the application is going to use. And they can use any one of them. You may be wondering, why did we actually have so many? Why don't we have just one? Right? Me too. I've always wondered this and asked my company, why the hell do we have 4 different layers? Why do we confuse the applications and everybody to give you so many different possibilities of getting an identity? And this is the answer I got. And I think, literally tell you, this is how all the insanity in computer software is defined. 2 words, application compatibility. Everything that you figure out is not working properly. If you have a problem with the system, why the hell is this written this way? Think of these 2 words, and you probably are very closer to the real answer of why somebody has been written this way. Why we have written this way? Hey, because OAuth didn't exist a couple of decades back. We were still providing identity. So there was some identity, some protocol that we were using at that time. And then we moved on to OAuth, which is a better protocol. But we can't actually take the customers who are already using the previous protocols. So that keeps stacking it up. That's how you build the legacy support, the legacy pipeline. Is it good? Maybe not. We have to probably kill some of these pipelines going forward. But it is an amazing opportunity for new researchers because the more complex this is, the more code is in the background, which has possibility of doing bugs. Like if you have just one entry point, the chances of finding bugs are lower than for guarantee. With 4 and maybe more, I will list all of them, there is much more higher chance. So this is the whole point game understanding. Alright, so let's talk about the protocol itself. I just talked about the getting into the protocol, but what is the actual protocol? What is the underlying thing happening on the background? Who are the players? We need to first understand that side before we get into the protocol pieces. So, a decade back, maybe more. I mean, we all have been on this cycle where there was a time when every application has their own username and password login screen, right? So here's a user, here's an application who wants to get to identify you. So they'll ask your username and password. Well, good. So it's gonna ask your identity, and since it is relying on its own self at this point, it's going to keep a database of passwords within itself, and then match, let's say that hey, you are the right guy I was expecting. Yeah, okay, we're going to go. Imagine the same scenario with other applications. So now we are in a problem space where every application has your password databases. Not a good security problem space, right? Let's look at this picture from two perspectives, from the user. So user has to have username and password entered for every application it builds. Plus, users are supposed to keep all the username and passwords unique, different. They generally never do. They want to keep one username and password, use it across all the applications. That's a nightmare for applications, right? Because even if one application gets owned or hacked, the database is gonna just get available to everybody, and now the database carry passwords, which is need the same password used across other applications. So neither users are happy in this scenario, nor the application owners. And on top of this, application owners are supposed to provide a functionality for their applications. They don't care about user identity. They have to, in this scenario, obviously they have to protect the databases and have these all jargons that they have to think about. So instead, they did what everybody did, outsource. So how about we outsource the identity to a third party, identity provider. So the idea is the application registers itself into identity provider and say, hey, I am an application who could be using users. So why don't you just register me into your space? And there's a trust between the identity provider and the app itself. So if identity provider brings back a token or identity of a user, which is signed by ID, the app should be able to trust it and say, yes, I understand. This is you are right. I know who you are. I know understand your token. So I agree with your identity in this case. So it solves the problem, one, from application perspective, because application has outsourced its side of security to actual identity providers, whose job is actually to secure the identification itself. So they are really solely doing this for that purpose. So their business is in that model. The users are happy too, because now they don't have to carry multiple users and passwords. They can basically replay and say, hey, all the applications can use the same identity provider, and then they can replay their own user and password for all. So it's a win-win situation for all the three players that are in the system. How does the actual flow happen from the website itself, from looking at the protocol perspective? As an example, let's go to portal.office.com. So portal.office.com is an application. It says, hey, okay, I get this new user, I've never seen this before, who are you guys? I don't know you at this point, so I'm going to redirect you to my identity provider. So literally the application is going to make a redirection to the identity provider, which is login to Microsoft Online in this case. Login at Microsoft Online will ask for your identity. Really, let's step into this layer of redirection because it has the most important critical piece of information for identity protocol. Also. This is the redirection that happened from the application whenever you are asking for login the first time. And it has multiple pieces. I'm going to walk through the pieces one at a time so you guys can get a glimpse of what happens. Why is this generated the way it is generated right now? So obviously the first line itself, the yellow one, talks about what is the authentication protocol I'm going to be talking to this identity provider. So OAuth 2 is being used, which is kind of an imperative indication that I'm going to be calling an OpenID protocol. The second thing is, hey, the identity provider need to know from whom this request is coming, this redirection request is coming. So the client ID is the application identification. So this client ID is for portal.office.com, who redirected a user to their identity provider site. And this information is important because otherwise, identity provider wouldn't know who is this information coming from, who is this request coming from. Third piece is the scope. Scope is very important. You probably want to note this as we go along as well. Scope is about when you are asking for your identification, you're just not asking for ID, you're asking for what do you want to do with the ID? Like, what is your goal at the end of the day? So application is saying, hey, I want an identification of this guy to read mails on his account, or to know who this person is, right? Or what groups does he belong to. This piece of certain information of what are you looking for in that identity is what constitutes your scope. What is the scope of your request in which you are generating this quotient for the identity provider? The next is, for an identity provider, it understood, okay, this ask is coming from this client ID, this application. It is asking for a scope to do something like profile information in this case. But how did the identity provider respond back? What to respond back? Like, what is the purpose? We ask this information to give you an identity, right? So there are various ways of providing an identity. We talk about there are various ways of providing tokens. In this case, we are saying what to respond is code and ID token. Just hold on to this information of what these code and ID token means. On a high level, think about this is information that the application wants to be written back from the identity provider. And this is the identification of the user. Then the idea is how to respond. Like, should I respond as a post request, as a fragment, as a query? There could be different ways how you want to respond back to the application. Again, this has gone to the ID, and ID is taking a portion at this point, saying, okay, I understood this. But how do I get this information back? Right? And this is how piece of that puzzle. Now the last piece is, where should I respond this information back? Because if you think from end-to-end perspective, this request generated from the client, from the user to the application, and then application did a redirection. And the redirection is on behalf of the user itself. It's running in the context of the browser of the user. So the user or the ID has to know, once it is done creating all this what is expected, where should I actually give this information back to? And just to get you an idea, what does that mean is, this is the flow we were looking at. The ID actually created a redirection back to the browser saying, hey, redirect this information to go to portal.office.com, and the code and ID is the information I want you to redirect to the application. And the browser just knows that this is a redirection again, so it's just going to do a redirection to the application. And the application, when it comes scattering code and ID token, it knows what you want. Let's talk about ID token now, before I go to code. So ID token is your identification. It's literally talking about in a format saying who you are, what is your name, what is your email ID, what is your IP addresses. It could be have multiple other information inside it, but it is literally talking about who is the representative of this token that IP is generated. So when you go to an application, it says hello Vishal. That information about the name itself is coming from IP token. That is the only way from where the application can gather that information. Let's look at the code side. So the difference between ID token and code is ID token is just about letting the application know who you are. It still doesn't have any privileges. Like it doesn't actually do anything on your behalf. What I want, for instance, an example is a calendar app. For a calendar app, you actually go and fetch the content from calendar resource at the background. You need to make impersonation request as a user. Right? As a user, the application should be able to impersonate you and fetch that information, because otherwise, this resource provider will not give you that information unless it knows that it's the user who's calling it out. So the code is actually used for that purpose. So code is actually a segment or one piece of the puzzle which is required for the application to finally convert that into a token which can be used for impersonating the user itself. In my calendar app scenario, when the initial redirection happens, I got the code and ID token. I can use this code, go back to my ID server and say, hey, I have this code, I know this user, and I want to fetch the details about this user, but I can't do it unless you give me a token on his behalf, which I can replay to any other service in the background. And that's what this code is redeemed for. And this is an example of a token which comes back. And this is what a bearer token is how we call it, but we don't have to think about it. It's a token which is a representative of a user. And it means that you can actually take this token and represent him in any format. You can take it out of the context, replay it, and then you are representing the user itself. Right? So this token is very important. This is pretty much the identification of the user itself. This token has few fields to it. One is a header, which talks about what kind of token is it, what is the protocol being used, what is the algorithm being used. Pretty lame details at that point. The second is more important, which is about the claims. What does this token claim? Who does this token belongs to? What privileges does it have? What scope does it have? Can it actually read mails on behalf of this user? Can it read documents on behalf of the user? Whatever you can think of has to be defined in the scope. The third piece is the signature. So anybody can generate this token, right? Remember the trust I talked about between the application and the ID? This is used when it's part of the signature itself. So when you sign this token, nobody can tamper the token itself. And the signature carries the validity that, hey, this token is generated by a party which is totally trusted by you, so you should go ahead and use it without thinking twice about it. So that's why signature is a very important piece of this puzzle. All the bad items I'm showing are kind of red flags, which is kind of the weaknesses in the system. One of the weaknesses that you can think of, okay, what if the signature is not visible? What if the ID provider forget to add a signature because of a bug? Right? What can happen? Somebody can generate the same token, manual the data, make a different user in the data, in the claims, change the scope to whatever he wish, replay it to the server, and the server will start accepting it based on checking the signature. Right? So it's a big problem. And if you have followed the Black Hat talk recently, this was actually discussed, and we paid out $200,000 to two researchers who found the same vulnerability in these period of time. Why did they find the same vulnerability during the same time is actually very interesting and might be interesting for all the researchers to know about. There are two basic principles from what I've seen over the years, what makes a researcher tick. What makes them a real deal versus a lot of other researchers who falter in not getting the highest value. Two reasons. One, You have to be persistent. Persistent with your whatever the area you are focusing on. It's very important to have a good knowledge on what you are trying to work on. So in this case, the guys who were actually focusing on were focusing on identity big time. They didn't find bugs in the first 2 months, but they didn't stop. The second, and which what triggered them to find these bugs, was a new feature that we added into the system. Always keep an eye out on the new features that always being discussed publicly about Microsoft or whatever. It doesn't have to be identity itself. It can be relying on any other bug bounty program, any other scenarios. Anytime a new feature comes in, go back on. These two guys were actually looking for this new feature that comes in and found this bug within a 1 week's kind of within each other. So yeah, that is a trick of finding bugs which are very strong and noteworthy. Alright, so we are going into the what if mode, and this is about more scenarios I'm going to throw at you to talk about what can go wrong when we're developing an identity protocol. So we talked about a scenario where, hey, I created this redirection which creates a token, redirects it to the redirect URL, right? So in the normal scenario, everything works fine. The token ends up getting into portal.office.com. What if I play around with this redirect URI? What if I give a link like this to a naive user and let them click on it? Is my ID gonna redirect to Google.com site and give them the tokens for that user? Valid question, right? Remember, when application registers themselves to the ID provider, they provide few information. One is what is your application ID, which is generally generated by the ID provider itself, but it is fairly static. Once you have it, you will keep it. The other information that is very vital during registration is the app URL, which is saying for this client ID, where am I supposed to be redirecting my users to? Right? So if the client ID and the URL doesn't match, then identity provider is going to say, that is not matching, that is not the right place I want to be redirecting your users to. So obviously this link that I shared is not going to work. But what can work is something like this. It used to work, obviously we fixed it. To make it more easy in visualization, this link actually has portal.office.com in there, right? So if I'm not parsing my URL properly, I could be thinking, hey, okay, this is saying portal.office.com, fine, redirect. But when this goes to the browser is looking at it totally differently. It has its own protocol to understand that it is actually broken into a different way, right? So great bug. Somebody found a way of breaking our filtering itself, which ended up finally to global Google.com side in this case. Yeah, I'm going to keep throwing these in, but I'm going to not talk about it. The idea is these are big bugs that are being found by users like you, like researchers like you, and they're drawing great boundaries around it. They're amazing bugs. Now the what if scenario. What if I register an application, a malicious application with ID provider. So I get my own client ID, and then I make a redirection to the right? All identity is checking if the client ID and redirection matches. If it matches, then it should go, right? This was the idea. If these two fields match, good. I'm going to get redirected, and my users are going to get the credentials of the tokens of my users. Well, there is just one thing on it. So Office.com is a privileged application because it is written by Microsoft. It's a first-party application. It has a set of privilege which allows it to do implicit authorization, which means that there is no constraint. This just works seamlessly. There is nothing that comes in between. But if you are a third-party application, you're going to see something like this. It is basically asking the user, hey, this application is asking data on your behalf. Are you okay to allow this guy to move on? And if user says yes, the application is going to get your data. This is a security boundary from identity perspective. This is a security boundary from all identity perspective. A consent screen which talks about whether you're allowed your data to be given to our application. And you can see obviously there is a scope within here which talks about what kind of information are you giving. Like you may not want to give all the information to every application, but you may be okay to give a profile information about who you are to an application. Keep an eye out in general, not just as a researcher, as a user, for what you give permission for to an application. This is the vital piece. You might see a scope like, hey, persistent access to your email account. It means once you agree to it, it means that the application has complete access to your email account all the time. It's not going to ask you for your credentials again. It's going to just use your credentials and move on. So like I said, this is a security boundary. If you can bypass the security boundary from security standpoint, the whole model of identity is broken. And I'm going to talk about a few cases as I go along where this model is broken. And before I go to the next slide, I want to talk about this implicit authorization which Microsoft have for first-party application. Not a good sign. It's amazing sign from researchers like you who can actually exploit this. Anytime you lower the barrier from security standpoint for usability, there are going to be holes in the system. And you should actually see this, like I'm calling out, these are the weaknesses in the system. You should try and, when you are contesting identity, you want to focus on this as one of the areas you look into and see if there's anything wrong with it. One of the things that I can say is, if you are aware of subdomain hijacking issues, subdomain takeover issues, which is, hey, some subdomain is taken over because Microsoft didn't do a good job in keeping their DNS profiles properly, then a third party might actually end up getting this exposure of Office. And in which case, the first party implicit authorization totally killed. And again, keep an eye out. I'm not going to give you much information on this because obviously I'm going to get fired. Alright, so OAuth in a nutshell. This is a recap of OAuth itself to give an idea of what we discussed so far. So OAuth is all about an application asking access to a user account. It talks about the scope, in what context does it want to have access. User get a consent, whether it approves or not. In some cases it doesn't because they have implicit approvals. And then the application gets a magic delegation token which it can use to investigate. So yeah, pretty much like I said, the middle layer is the security boundary. If you cross that boundary, it is game over. I'm going to give this out because some amazing researcher actually gave us this content a few years back or so. I was thinking it like, oh, he got paid amazingly for the bundling form, but he's still I don't want to put anything bad on OAuth. OAuth started as an amazing protocol. What happened over the course, when it started getting overloaded, it was not supposed to be authentication protocol. It was designed to be authorization protocol. And then we started using it, saying, hey, it works amazing for authorization. Let's try and work it for authentication as well. So we started piggybacking on it. Now we're in a state where it is kind of a mess. Still amazing protocol, much better than other identity protocols. But you can imagine the more complex the protocol becomes, the higher chance of it finding behind bugs in its implementation. Okay, if I'm a researcher, if I see this one line, two line, I don't know what you guys think. I have one thing in my mind that comes into my mind. Can you guess what it is? Where is the NTCSR form request? It is a post request which is being created within the context of an application. Where is the token? If there is no token, can you imagine what can happen? I, as an attacker, can actually send you this request from a different browser tab. Right? So I can make you click on some random link. And that link is going to make a call out to this URL. Since there is no CSR token, there is no way for the application to know whether this is a legit call coming from a real application, or is it being created by somebody in the background as a hack. But CSRF actually gives you a protection saying every time a legitimate application creates a form like this, form request like this over post, it adds, okay, you want to do this? Yeah. Thank you. Now if I flop, I'm gonna, yeah, blame it on the brain. Alright, so CSRF, very important because that authenticates the validity of the post request. Otherwise, anybody can make the request on your behalf in the background, you wouldn't even know. One of the basic principles of web security is within that origin, if there is a cookie, like if there is a cookie for login Microsoft if you make a request, the cookie travels with. Whether you like it or not, all the cookies that are defined for that domain is going to travel with it over the traffic. And that's why, if this is made outside the context, you will still be used, your cookie will still be used, which was used for authenticating you. So the request will be made on your behalf. So what would happen? In the back scenario is, hey, I actually make a call from a different tab and register my own application. Because you just said you're consenting to it. That's the URL for where you consent to the application. There is no consent screen going to show up because I control that screen now. So I can basically hide that screen from you, click up the button itself on your behalf because I am running my own JavaScript. So it's and like I said, this is a security boundary which is broken the boundary. So what? Now the application name is not encoded on the consent screen. What happens when things are not encoded? XSS, right? So this consent screen which has an XML, which is obviously not harmful in this case. But what if I can run a JavaScript instead of that small snippet that I showed up there? Well, the JavaScript is going to click on that yes button on your behalf. It won't even ask you after that. So this is going to be transparent to you. So what will happen is, I create an application name which is a JavaScript element, which is going to find the element of yes button on the page, click on it, and move on. So you wouldn't see this consent screen in the first place. So again, the boundary is broken, which was really the boundary which was protecting the consumer. Bunch of other XSS, these are all reflected XSS. I'm not going to go into details. The idea is there are a lot of bugs. The bugs are also because one, the protocol is complex. Two, we have made it complex by having so many different layers. Like, look at this. So you have login on MicrosoftOnline.com, we have login on Live.com, and then within itself there are multiple other protocols which are being followed, which has their own parameters. So you can play around and yeah, but it's a party at this point. And this is one slide that I absolutely love because this actually gives an amazing idea of why diversity is so important in finding bugs. I've been in the security industry for 12 years now. I don't think I would have found this bug, even if I was looking at this for the whole week. Apparently, the researcher who found this bug was researching in this area. The area is called reflected phenomenon. He was like, okay, reflected phenomenon, let me try it on login on MicrosoftOnline.com. He happened to find this URL, which really sets him up for what he was trying to do. The tool here is what it's going to do is it's going to download a file named setup.bat, put the content that is after user equals to code, equals to whatever it is, like cal in this case, put that inside setup.bat and ask user to download it and make it run. I mean, this line itself wouldn't make it run. There is still a social engineering element involved here. But the fact that you end up getting a download from a trusted location is a good sign for most of the users who actually go and click and run. And looking about, there's still a lot of layers in between to finally get the execution. Like from security standpoint, every time you ask a user to do something extra, the severity starts going down. So this is in a very high severe case, but since it was a diverse, amazingly different case, which like I said, I wouldn't have actually found myself, there would be something that we had a paying because of just the sheer way of how somebody found this in a different sense. Coming back to the slide, I mentioned having so many variations is not helpful from us. For you guys, it's an amazing thing because now we have so many different layers which you can trickle down, try different variations of attacks. If it doesn't work on one of the layers, try other layers and see if it works instead. So yeah, I mean, again, this is great news for you, bad news for me. I'm working with my teams and see how we can actually get it off of it as soon as possible. But till that is gone, you guys are happy to have a copy of this. Alright, this shameless plug I was talking about, not so shameless because Microsoft has a bunch of bounty programs outside Azure and hypervisor. Identity is the biggest bounty payout that we have exposed to. I tweeted this recently about a researcher at the who found a $40,000 bounty in this program. And you can imagine which one was it. He actually found a significant authentication bypass with amazingly high quality information. So he got 40K. There are a lot of bugs in there. If you start looking, hammering it out, it's not going to be easy. It's going to take a bump of learning what you are doing, but be persistent. Look out for new features always. The scope is huge. It's not just logging on Microsoft Online or logging on Bank.com. There are a bunch of other properties that you should go after, which increases the scope significantly. To go after it totally. Okay, I'm going to conclude the talk itself with this message that we saw earlier. So imitation is the system of flattery, right? It was good maybe in 19th century, in 20th century it is not. Here's what we call as identity theft, and we don't want to be in that game. Here's a great example. What is it? It looks like a pizza hat, and with a black hat kind of logo on it, but it is neither of those. So this guy has taken it to an extreme where they copied two well-known identities and made it their own identity out of it. So security is hard. Everyone knows it. Nobody complaining about it. And that's the reason why we want to expand the horizon from Microsoft perspective to everybody. That's why we have such bounty programs to involve everyone. Because realistically, within us, I don't think we could have actually achieved what we have seen in the slide itself. Like, there were so many bugs which were identified by external researchers. And I think you guys are in great shape to scale this further as we go along. The first point I made, identity is literally the key. You can scale the walls, you can go through the drains, I don't know, you can find different ways to get into the kingdom. But if you have the key, you don't really have to do any of this. And once you have somebody's identity broken, the application model is totally gone. It doesn't matter whether there is an access set on it or a SQL injection, like the SQL injection is more critical than the server side. Any client-side bug is not as critical as an identification broken system. So that's why key into this kingdom is identity. That's why we have so much focus. That's why we have such a high boundary payout for this. It's not just for Microsoft. For every identity provider, this is the biggest problem space in the world. So keep that in mind. There are some references. I've used some of those in my talks, so you can take a look at it. I'll share the slide deck. I don't know how, but if you reach out to me on my Twitter, I'll be able to share it. With that, if you have any questions, just a plug. So we have a panel discussion tonight at 8 for Microsoft and Cloud folks. If you have any questions around those, feel free to come by. We'll do very open, candid discussions around what we have discussed. If you have anything you want to share, any knowledge you want to gain, we'll be happy to answer you.
There's something we want to share.
Alright, with that, I am done. If you have any other questions, I'll be happy to take them right now.
Here, we wanted to share it.
Oh, thank you.